This is going to be more of an overview talk, talk about all the different ways that you can do client-server communication. Following this talk, if you're interested in what we have, GWT Rob Jellinghaus, who's at the back, will be giving a detailed talk going into a lot of the details of that. So this is an overview of the things we're going to talk about. The different protocols you can use, GWT SOAP, XML various forms of JSON, REST. We're going to talk about different communication methods, such as being able to get communication from the server back to the client, forms, iframes, and talk about best practices. So, for example, stateless servers so you can scale better, handling failure on your network communication, and some data model concerns for what sort of data you want to bring to your client and what do you want to keep on the server. So talking about the protocols, pretty much anything is possible. We're just going to give the overview of these particular ones. GWT is what we've built into GWT. It has some advantages. We'll get into that. But again, pretty much anything can be done. You'll just have to write more of the code if you aren't using something that there's code already available for. The benefits of GWT, it comes out of the box. You don't have to write any code to use it. It's type safe, so like a traditional Java remote API, including exceptions. You can serialize entire object graphs, including cyclic ones. So whereas JSON and some of the other methods, really you're only getting primitives, arrays of primitives, things like that. In this, you can actually send an entire graph of objects, including if there's self-references in the graph. GWT automatically takes care of that. Now you have to be a little careful because if you wind up shipping down thousands of objects, there's some issues associated with that. So if you have a data structure that refers to a lot of objects, you want to be careful about actually sending that entire data structure down. You can share code between the client and server. So you have your, say, POJOs, or you have some logic that deals with your data elements. That same code can be shared on the client and server. One of the other speakers here who has done some pretty impressive applications, he is using the exact same code running in Java applets, running in Java on the server, running in GWT in the browser, and running in Android in phones. So you can actually get a lot of leverage on your existing code from that. One other benefit of GWT is it uses an asymmetric protocol. So for example, we try very hard to make sure that the JavaScript execution in the browser is very efficient. So when we're sending down data from the server, we're sending exactly what can be parsed with minimal effort in the JavaScript interpreter. When we're sending it back to the Java side, we're sending what can be produced very efficiently by JavaScript. So that's one thing that you get with GWT that you generally don't have with the other types. Like if you're using JSON, you're sending JSON both up to the server and back from the server. So the bottom line is, if you're writing new code in Java on the server, we recommend GWT. If you have legacy applications on the server that you're trying to interact with, you're probably going to use whatever you're using on the server already. So if you can, try and use GWT is our suggestion. For a sample of what this looks like, let's say we wanted to find a lookup service that is going to look up a person record from a name. So we define an interface, and notice that it extends remote service, which is a GWT class that's supplied, and it returns a person record given a name. You could also have throws clause on that, declaring what exceptions it can throw, etc. One thing about AJAX applications is it needs to be asynchronous. If you block waiting on something from the server, basically the whole browser locks up. So the user can't click on anything. sometimes the Chrome even stops painting the window in the browser, things like that. So the way we handle that is you actually also declare an asynchronous interface. And the only difference is basically instead of returning the type, it returns void, and then you pass an asynchronous callback, which will be called when the data is available from the server. So this particular example is using generics, which is a feature that's in GWT 1.5. It's currently available in the trunk. If you're using this with GWT 1.4, you would just have async callback, no generic parameter, and then you would have to cast the object to the appropriate type yourself. So this is a little bit cleaner interface, easier to read, and allows you to use the generic support. Here's an example of how you would actually use this. So you declare the variable that's going to store the interface for the async interface, and you call GWT create, passing it the synchronous interface. GWT create is special in that the compiler is actually going to generate code for you. In this case, the RPC generator, since lookup service extends remote service, it knows that this is something that the RPC generator needs to apply to. And then it will generate the code on the fly for you at compile time, and it will generate it as part of your deferred binding, so that if you have different like locales, different browsers, it all gets generated optimally for each one. Then you set the entry point URL. That would be like the URL on the server that the servlet is running as. And then we call it just like a regular function, and we pass a callback. In this case, we're using an anonymous inner class, and we declare an onSuccess method that when it gets called back, it receives the person value from the lookup person call, and it does whatever it wants to do with it. In this case, it's calling a show person method on the detail panel. We also have an onFailure callback in this that can retrieve any exception that was thrown on the server. In addition to the normal exceptions that your servlet might throw, you can also have an invocation exception, which is if there was actually a problem getting to the server. For example, the network's down, there was a version mismatch between the client and server, things like that can result in an invocation exception. Here's an example of what the code actually looks like on the server. It extends remote service servlet, and it implements our lookup service interface. So it provides the synchronous interface that we defined earlier. In this case, takes a string for the name, does something to find a person object, and then returns that person object. If it wasn't found, maybe you could throw a person not found exception or something like that, or maybe return null, however you wanted to handle that. So the server side looks pretty much like you would expect for a typical servlet that's being called through RPC. Some of the limitations with GWT RPC, first of all, it's asynchronous only, but that's pretty much going to be true for anything you're doing in AJAX. It's technically possible in some cases to do synchronous operations, but you really want to avoid that because, as we mentioned before, you can lock up the browser from the user. Also, the client must be compiled with the types that can be sent by the server. With Java RMI, for example, you might receive subclasses in the call that you never saw at compile time. But in the case of GWT, it actually compiles everything all at once, monolithic compile. The compiler makes assumptions based on all the types that it can be. So, for example, if you have a vehicle class and the only vehicle subclass that you ever use is car, the GWT compiler will actually make it so it static calls to the car methods rather than virtual calls through a vehicle. So one of the implications of that is that all your types have to be known at compile time, including the ones that it's going to receive over the wire. A consequence of that also is that your shared code that's going to run in both the client and the server must be translatable. And what we mean by that is GWT doesn't implement everything available in Java because of the limitations of the platform. For example, we don't support reflection, class 4 name. There's a few other things that aren't actually implemented. So your shared code has to be the subset of Java that can run on both the client and the server. There's also some serialization issues. In Java, for example, if you declare something to be serializable, you can declare read object and write object. And what those, you have creating actually a binary format on the wire for these. And then you can use reflection to generate sort of default implementations of those. Well, we don't have reflection, and with JavaScript, you don't want to deal with the binary format on the wire either. So things have to be subject to the constraints for GWT serialization. You can also have a custom field serializer, which is a specially named class that knows how to serialize a particular one. But just because something is serializable with Java does not mean that it's serializable with GWT. And again, for JSONRPC, I'm just touching on an overview of it. Rob is going to be talking in detail following this talk, and if you want any more detailed answers, I suggest sticking around for that. Another common protocol for AJAX applications is various forms of JSON. And the basic idea is you send data from the server that is directly parsable by JavaScript. So, for example, you may send an array of strings, and you simply evaluate that array, and you can directly access the values. Since GWT ultimately compiles to JavaScript, you can always do this just as efficiently as you could in JavaScript. The one thing that you can get extra is GWT allows you to put layers of abstraction on top of that without really having to pay anything for those layers of abstraction. I'll show you some examples coming up. One very important thing, since JSON is actually executable JavaScript codes, you really shouldn't use JSON if you don't trust the server. There are some things you can do. For example, the JSONRPC talks about a regular expression that if this JavaScript or the JSON response matches that regular expression, it's safe to evaluate. There's still some security issues there. So again, if you don't trust the server, I would recommend not using JSON. Here's some GWT code that would talk to a JSON server. One of the classes that's commonly used for directly executing requests is Request Builder. You can think of it as sort of a generic and extended XML HTTP request. So you create the request builder. We're going to do a post to a given URL. You can control the headers in that request builder. So like if you need authentication set in the headers, cookies, things like that. You send the request, and you can pass data up to the server as part of the post. And just like we saw with the JSONRPC having an asynchronous callback, we pass a request callback object. In this case, it'll get called the onResponseReceived method when it successfully completes. We have another function, which I'll show on the next slide, that takes the text from the response object and builds our own object from that, which models the JSON data. Then we call some method on it, getting the name from this JSON object, and then passing it on to some other method. And like we saw before, there's also an onError method, which is called if there's a problem with the request builder call. So if the server didn't reply or it returned a 404 or 500, whatever onError would get called. Now this is GWT 1.5 syntax. So in GWT 1.4, you couldn't do it quite this easily. There's a JSON library in GWT 1.4, but what we found is with some of the compiler optimizations, that library essentially goes to nothing. So what we have is we declare my object to extend JavaScript object. And JavaScript object is a special object in the compiler that basically wraps a real JavaScript object in the browser. So it's a very minimal overhead. There's not actually any object around the JavaScript object. It really is using the JavaScript object. So in this case, we declare a field, and this is using JavaScript native interface syntax. So native in this case means JavaScript code, and the special comment syntax surrounds that. So we take this in this case is the JavaScript object reference, and then just references the field name on that object. The getJSON function, what it's doing is just doing a JavaScript eval and putting parentheses around it to make sure it's treated as an expression rather than some other code. If you did want to add additional validation, this is where you would do it. So for example, you'd test that it matches a certain regular expression, filters out any bad statements that could be in the JSON, et cetera. Personally, if you don't trust JSON, I don't think it's worth using. If you don't trust the server, I don't think it's worth using JSON, and then adding that just slows things down. So what this actually will get compiled to, if we go back to this first statement, this object.name, when it gets compiled to JavaScript, will actually be a field reference off of obj. So it'll just be obj.name. That's essentially completely zero overhead for using JavaScript objects directly in GWT. Again, this is only with GWT 1.5, so what's available in the current trunk will support this. With GWT 1.4, you actually have to use the JSON library, which adds a little bit of extra overhead to that. JSONRPC is pretty much the same thing as JSON, except there's special conventions for passing arguments and return values for RPC. Basically, it's known field names in the objects, things like that. So the code's going to work pretty much the same way as what we just did before. We just have to follow the conventions of what field names we use, things like that. One other advantage of JSONRPC is you can actually do server-to-client RPC. So if you have the server code calling a method in the client. Now, there's some other issues of how you actually get the server to contact the client, since it can't open up a socket, talk to the client's browser. The client's browser has to be involved, either polling, doing hanging gets, things like that, which we'll cover later on. Still subject to the same origin problem with all these, which is you can't talk to a different server than the one that you retrieved your JavaScript from. There's ways around that, which we'll get to in a second. Another feature of JSONRPC is you can do notify-only messages, which are like RPC calls, except you don't actually send a response back. So here's an example of what JSONRPC looks like. If we have the first case, the client going to the server, it has an anonymous object with a method field, and the method name is lookupPerson, and then we have another field, params, which passes an array of strings and then a second array. The ID is what matches up on the response. You can have multiple requests in flight at the same time. So here's an example. We send a request from the client to the server. The server replies with the result, which gives the two matching records to the lookupPerson request. Notice the ID matches. And the server also, at the same time, sends an RPC call to be executed in the client. So, and then the client makes another request back, sending the response to the server, the result from the warn user call. JSONP is an extension of JSON, which allows us to get around the same origin limitation. The basic idea is you put a script tag which can reference other servers than the one that you're currently running from. And in that, the URL for the script tag, you have a callback function which will get executed. So what happens is the server will fabricate executable JavaScript code containing the data as a call to the function that you've requested. Google's GData APIs, for example, support JSONP. since most of your applications that would be accessing GData APIs are not running on Google servers, so it's not very useful if you can't access a different domain. Here's an example using the Google base. The URL, notice it has the alt equals JSON in script. So in this case, that's telling it to return JSON in a script tag rather than the Atom XML. And then the callback specifies a callback function. And this will be actually a JavaScript function that gets called. And so on the next slide, I'll show how you set that up. Then making the request, we'll call a function which we'll define next, and then we get a callback, and we use the response just like we did in the JSON example. So what the JSONP request function is doing is it creates an anonymous function in JavaScript, sets it on a known parameter on the window object as my callback, which is the same name that we passed in the JSONP tag. And then that function actually calls back into the Java code in GWT. This is the special syntax. If you haven't seen it, the @callback::callback is referring to the Java name, and then the my_response is the JNI signature. The problem is that JavaScript doesn't have types, so you have to specifically specify which Java method you're wanting to call with this. Then the way we actually create the call to the server is we create a script element and add it to our body. The browser will go fetch the URL associated with that script, which in this case the server will send back executable JavaScript, which will then call our my callback function with the actual data from the response. That function will then call our Java callback function, which is here. We use it directly, the JavaScript object fields directly like we did before. One thing that to notice on this is a little toy example. One problem is we have a fixed callback function name. So you can't have two of these in flight at the same time because they're going to be both going back to the same function. Some JSONP implementations, there's an additional parameter you can supply in the URL, say like a context parameter, which will get sent back from the server that you can match up the response with the original request. So for example, you can keep a hash map of the callback functions by some context name. The other problem we have is that we're just creating these script tags and appending them on the body. Eventually, if this is a long-running app, we're going to have thousands of these, and that's not a very good solution. So to make this a full solution, you'd really need to do some sort of garbage collection on that. For example, in the callback function, you could actually remove the script tag that was created for that callback. The other problem to deal with on this is we don't get any positive confirmation of failure. So if the server is down, what happens is the script just didn't get loaded and didn't run. So the only way that we can detect that is to set a timer. So what you could do is you set a timer. If you didn't get a callback from the server in a certain amount of time, then you treat that as a failure. And then you would clear the timer when you did get a successful callback. So those are some of the things that you would need to think about in doing a real implementation of this. XML_RPC is a predecessor to SOAP. It takes the same basic idea as JSONRPC, except we're using XML instead of JavaScript code for requests and responses. It predates SOAP and is a lot simpler than SOAP. We'll go down SOAP a little bit later, but as you can see, it's basically the same sort of thing as the JavaScript code, except we're sending XML. You have the method name to invoke. You pass a tag with parameters, and then you pass the individual parameters inside that. There's additional type flags for what the actual parameter types are. And here's a sample response, which looks pretty much the same, except you don't have a method call. And there's a different format for failures. The way that we parse this, we do the same request builder. So we create the request object, we make a request on the URL. This is our callback function for on response received. Instead of, after we get the actual text, instead of executing it as JavaScript, we use a GWT library function, the XML parser, and it basically builds a DOM structure out of the XML. You would also need to handle errors in this case, such as if it's not a well-formed XML document. Once you get the document, then you can do your normal DOM operations on it. So for example, we can find all the tags named param and get it in a node list. And in this case, I just went directly to the one I wanted, which is the inner John Doe string value. So we have the param, inside there is a value, inside there is a string, and so we just go directly to get that value. In a real application, you would want to do more validation than that. You would want to make sure that it's the structure you expect. You would want to check for the failure code. In this case, the params would be null because there would be no param in a failure from the XML-RPC server. You'd also probably want to verify the type, making sure it's the type you expect, especially if you're taking these values and then you're passing them back into Java code. If you think you have a string, but you actually got an integer, you'll get a failure at runtime of a class cast exception because the GWT compiler is going to believe whatever you tell it is being returned from your JavaScript code. SOAP is basically a larger, more complicated form of XML-RPC. The origination of XML-RPC was a couple of guys at Microsoft and a person outside of Microsoft working on it. The guy who was outside of Microsoft got tired of waiting for it to be standardized, basically went ahead and published XML-RPC. A couple more years went by of design by committee, and we wind up with a big, complicated spec for SOAP. One thing it adds is WSDL, which is an XML document that describes the service and the types involved. You can create new complex types rather than just the built-in like string, integer, etc. There's tools that exist for many languages for building a client interface from a given WSDL. In GWT, it would be possible to do this using a generator that at compile time would read the WSDL and then produce the client-side code for you. To my knowledge, that hasn't been done yet. So while it is possible right now, you'd have to do it by writing a lot of XML parsing code similar to what we saw in the XML-RPC. Here's an example of what the SOAP request response outline looks like. Again, it's just XML. There's an envelope which has namespace definitions, so you can pull in your own type definitions, things like that. There's a header which might have authentication information, and then in the body it'll have regular XML tags with data. So if you are building this for a request, then you've got to build all this large XML. You've got to pull in the right schemas, things like that. When you're looking at the response that comes back from the server, you have to go look through the tags, find the data you want, handle errors properly, and so forth. So SOAP is a big, complicated mess to deal with. And without having the tools for it, it's kind of wordy. But in some cases, for example, in large enterprises, there's a lot of SOAP applications already. You're probably going to have to do that to integrate with them. If anybody does write a generator, feel free to contribute it. We'd be happy to have it as part of it. Representational state transfer, or also known as REST, is another method. It looks like a typical web interface. So you have objects which link to other objects and pull in other objects. So an HTML page will pull in images in the page. It will link to other HTML pages, etc. So basically, whereas a JSON interface you'll have a URL that performs some action as an RPC call or something like that. With REST, generally the URLs are objects and nouns, and then you'll do get to retrieve them, post to update them, put to create new ones, etc., using the regular HTTP. Request Builder allows us to handle this pretty well. You can specify any of the methods through HTTP. The real complication is that REST itself just talks about a general approach. It's not really, here's a block of code you can use. So what you're gonna have to write is the actual code to deal with the object format. So one object might be a bunch of binary data. Another object may be an XML document, things like that. So you're gonna have to write the code to parse whatever data format you get and to produce the data in the format to send up to the server to do a post, etc. One nice thing about REST is that it can take advantage of caching. So a typical RPC, it doesn't really make sense at the HTTP level to cache the request. So if I'm doing a lookup call that I know the result of this may be cached, I really have to do that myself in my application. So I decide, I keep a local cache that, well, this name I've already looked up, here's the person record associated with that. I don't even bother to make the HTTP request for that. With REST, you can basically just have a URL that, okay, this URL refers to John Smith, and I can do a fetch on that URL. The browser can cache it according to its normal caching rules. The server sets the caching policy based on what it knows about how often this record will change. All right, so we've mostly been talking about the different protocols, and under the hood, they're pretty much all been XML HTTP requests. We did use the script tag for JSONP. So now we're talking about some other ways that you can do client-to-server communication. For example, if you need to have the server making a request to the client to do something, you can do hanging gets, or it's also frequently known as comment. There's a lot of different ways to implement that, and there's various issues along with each one. Another thing you can do is you can use forms and do posts up to the server. For one thing, if you want to get files from the client's machine up to the server, this is the only way to do that, is using a file upload in a form object. Also, if you're dealing with CGI code or a CGI style code, frequently the only way you're going to be able to communicate with that code is using form posts. So in some situations, that's really going to be your only option. Iframes are another alternative. Before XML HTTP requests came along, this was a way that people used to get data at sort of an RPC style interface from the server to the client. There's some issues associated with that, but it still is in use today. For comment and hanging gets, basically the idea is that the client keeps a request open to the server, and then the server responds when it has something to send. So for example, you might, if I do a get on a URL, the server just does nothing on it. It sits with that thread open. When it decides it needs to send something to the client, it just goes ahead and responds to that get. The client might then immediately turn around and issue another get for the next time the server needs to talk to it. One of the big problems with this is you're using up one of your two connections allowed. So if you have two connections to two different servers like this, you aren't doing anything else. There's also a problem on the server side because you're keeping a TCP connection open. There's some server mechanisms that can alleviate that difficulty some, but in general, if you're doing this, it's going to cause a real server load problem. You're going to wind up having more threads, you're going to use more memory, you're going to have more TCP connections open. You can also have firewall issues that you're keeping lots of connections open. So make sure that you really need this before you go down this road. So here are some of the ways that you can arrange to do this. I've already talked about the first one. One little wrinkle in that is you can do within script tags to get cross-domain RPC. So I create a script tag just like we did in the JSONP example, and then the server doesn't actually send anything back immediately. It waits until it has some data, and then it responds with the JavaScript code, which will call the function in the client. So we can just take the JSONP approach we did before, and we can extend it for server to client. Another thing you can do is basically have an infinite frame. So you create a frame that is being served from the server, and then the server periodically writes script tags to it whenever it has any data that it wants to send to the client. So it writes, flushes the socket, waits a while, writes some more data. There's a couple of issues with that. For one, WebKit-based browsers don't do anything until they've received a certain amount of data. I think it's like 1K. So if you're sending small messages, you won't actually get them for a while. Another is that some browsers will show like the hourglass or things that shows that it's still actively downloading this page because it's never finished. And that can confuse your users and generally make the browsing experience unpleasant. Another option is you can do multipart responses. So in the, you send a MIME type that says that this is going to be a number of different pieces. And you can access that through XML HTTP requests. You may have seen it in the 90s used for server push updating images. The problem is that only works with Firefox for XML HTTP requests. So it's kind of limited. Another thing you can do is the streaming XML HTTP request response. That's similar to the infinite frame, is you just periodically write data. You look at the onReady state change in the XML HTTP request, and when it's received new data, you collect that data, do something with it. The problem there is it's Firefox and WebKit only. Another option is HTML5 events, which is the new specification for HTML specifically includes a mechanism for generating events from the server, and you process them in JavaScript just like any other events, like an on-click event, etc. The problem is right now that's only, Opera is the only browser that supports that. It's not clear when or if the other ones will. Finally, another thing you can do is the client simply makes lots of requests to the server, and the server replies if it has anything that it wants to send to the client. And in general, I would recommend that you start with this first if you need to do server to client. And if you find that's not acceptable, either on the latency or if the load on the server, then you start looking at other ways. For example, at Google, we had some access that were done with hanging gets, and we had real issues on the server. Wound up changing to client-side polling, where basically it polls frequently, and we found that we can deal with the scalability requirements of polling a lot better than we can with the hanging TCP connections. For forms, as mentioned, this is frequently the only way that you can talk to a legacy CGI style application. They're frequently, they send down, create HTML, the user does things locally in the browser, then posts a form, the server processes the result of that form, sends down the next page. So if you have a big, large CGI app and you want to make it AJAX a little at a time, one of the things you can do is continue to use the forms to talk to the server and just have your client-side code be the one controlling that rather than the user actually clicking on the form buttons. This is also the only way that you can get the files uploaded to the server. So if you want your user to upload something, you're going to be using a form for that. In GWT, there's two classes that you'll be interested for that. There's Form Panel and File Upload. They're both in the ComGoogle GWT User Client UI package. Iframes can be used to pass information to the server by changing the URL. So if you have an iframe that points to the server, you change the URL, the server recognizes that new URL, and you can get information from that, such as query parameters in the URL. You can get responses back by looking at the content that's actually stored in the URL itself, or in the iframe itself. You can also send back script tags that are executed, which we talked about in the context of JSONP. Now, one thing, if you're running inside of an iframe and using the script tags, there's limitations on cross-domain for that. For example, in Mozilla, there's ways where you can actually call methods on a parent iframe in JavaScript, but not in IE, and in WebKit, you have to do it quite differently. So iframes generally aren't a good solution for that. Just putting the script tags in the top-level document works better. Some other issues with iframes, if you're using them for sending the data, when you create an iframe, it sets history states in the browser. So when you hit back, it changes what the browser is doing that the user would expect. In fact, GWT uses iframes internally to implement history support, so that when you hit the back button, you can capture that and show the user the proper navigation. There's also browser compatibility issues there. So using iframes for communication from the client server is really something, if you have code that does that already and extend it, that's okay, but I wouldn't recommend writing new code that way. All right, talking about best practices. If you have stateless servers, you can handle failure better, so that any server can handle any user's response. You scale by just having more servers. Stick them behind a load balancer, and you scale up to whatever load you need, pretty much. Another thing to consider is the different failure modes. Make sure you keep what the user needs in mind while you're designing this. For example, and there's too many AJAX applications that failed in this regard, that you do a lot of work, you keep all the state in the browser, you lose connection to the server, you just lost all your data that you put in the client. So some things that you can do to help with that is you can periodically save like if you're an email client, you periodically save a draft to the server. If you're on a machine with gears installed, you can store things locally, things like that. Another thing to consider for best practices is minimize the data that you send to the client. Not only does this save on the actual bandwidth, and there's still a lot of users that are on dial-up that you need to consider that, and it saves you money for the bandwidth on your server, but it also makes for a better experience in the user. If you have a lot of data in the browser tends to get slow. You would then have to keep that data updated. So if you have 10,000 rows in the client and 5 of these change on the server, well, it's a lot more work to figure out which ones you need to update, send down to the client. When we're talking about stateless servers, obviously any real app is going to have some state, such as kept in a database, something like that. So what we're talking about is really the conversational or session state. So as the user manipulates your application, moves around in it, that's the part that you want to keep in the client and not pass that up to the server each time. So for example, moving between pages, keeping track of which tab you have open, things like that, you want to keep solely in the browser. The user adds some item to their shopping cart. Obviously, you want to send that to the server, so it's kept there. Aside from the performance benefits of any server able to answer any request, you get failover benefits as well. No user data is lost if a server dies, because that's not where it's kept. So the user doesn't see some an anomalous behavior in their navigation state just because they switched to a different server. We talked about minimizing the data in the client, reduce the bandwidth both for you and for the end user, reduces the amount of update traffic that needs to go to keep this in sync. If you don't have any data in the client, you don't need to send updates to that data. One important point on this is that it's not just about the data itself, but say if you have 10,000 row data that you want to page through, you don't want to have 10,000 rows in an HTML table. The browser is just going to be sluggish. It's a poor user interface in general. So what you want to do is have your application actually page through that easily. So we have some tools to help with that. In the GWT incubator, there's a data-driven table object which does exactly this for you. At some point, that'll probably make it into the GWT main source itself. All right, that's pretty much what I had. We have any questions? Right. We have microphone. Oh. Okay. Okay.
One of the limitations you said for server push to the client was the two-thread or two-connection issue. Is that's cross-browser? So if the user has multiple browser windows opens or tabs, it's still a limit of the browser, not of your application. Is that right?
I believe the browser treats each tab separately, but I'm not positive. It might also be per domain, possibly.
So that could be a browser issue specifically then.
Right. It's not actually a hard and fast rule, but it's a recommendation in the exchange spec, and most browsers will follow it.
And the second question is, could you elaborate any further with regard to the Google apps that you guys started out with, the blocking or the hanging gets, and then decided to move over to the, okay. Just.
You can put your mic back on.
I understand if you're running it directly in browser, but if you're using something like SQLite local database, why wouldn't you then want to just pop it in there and then call it local for performance increases?
You mean like in a Gears application?
Yeah. Mm-hmm.
Well, you have to get that data down at some point, and that's going to take bandwidth. And then if it's data that changes, you have to make sure you keep it in sync. But certainly for largely static data, you could certainly improve the performance by downloading it to a Gears local database.
Yeah. Most of the data people are focusing on that they're accessing a site for is by definition non-static. And that's why the asynchronous actual tools are there to, because what you're going to do is make a presentation choice, the user is in the app. They're going to decide, I want to see this many results in this much space. And out of the local database, you could have in the background it updating it or giving real-time updates and the information, and then it choosing how much they want to represent at a time. It's just a staging issue, looking at your local system as a part of your server architecture.
Sure.
Any more questions? Yeah.
I was wondering, maybe you could go a little deeper on the method you recommended for server-client communication, the client polling.
Well, basically, the client simply makes an RPC request that is like a null request. It's just asking the server, do you have anything for me? And the server can reply saying, yes, please execute this method with these parameters.
Okay.
And, or if not, it just says, no, I don't have anything. And so you keep pulling as frequently as you need for whatever latency requirements you have.
Any more questions? More details on slides presented? Okay.
So is JSONP available only in 1.5, or is it there in?
No, JSONP you can implement even in the very first GWT versions. What was added in 1.5 is the ability to access JavaScript objects with very little overhead. So I can define my own custom Java object and declare that it's a JavaScript object, and I just directly access the fields off of it. So previously, for JSON in general, including JSONP, you would have to use the JSON parsing library, which adds a little bit of overhead.
Now, where is this JSON parsing done? Earlier, is it done on the server or the client? I mean, because I'm talking about basically accessing a legacy application to serve the data to the GWT. So that JSON parsing probably has to be done on the server, right?
Well, if you're sending JSON to the server has to know how to understand that. But if it's a legacy server that's already doing that, then really all you have to implement is the client side.
Yeah, but basically it's the getting around that same client limitation of a browser. You cannot go to any other. If the legacy application is on some other server, you have to get around that.
Right, so the server would have to support JSONP to be able to do that if you want to go to a different server. Another alternative is you can use a proxy. So you run a proxy on your server that is from the same origin that the JavaScript is downloaded from. And then it talks to a different server which has the data using JSON. It just tunnels that back to the client.